Okay, looking at the extreme value theorem, another one of the big theorems of calculus. And this theorem simply says that any function that is continuous, and notice the requirement of continuity does not say differentiability, but if a function is continuous on a closed interval, then that function absolutely will have a max or a min somewhere on the interval, and they could occur at endpoints. And you do need to remember the difference between a relative or a local max and min and an absolute max and min is a local max or min can only happen on the interior of a function. It cannot happen on the endpoints. And absolute can occur on the endpoints as well as critical numbers. And that is actually the answer to the first question. When asked for the max or min of a function on a closed interval, and that's really the key. They don't always say absolute max or min, but if they say find the max on an interval, then you're going to be looking for the absolute. And the first thing you should do is find the candidates. Like, what are the x coordinates where the absolute max or min could happen? And your candidates are your critical numbers and the endpoints. And so you always want to list the candidates. And on a free response situation, you'll frequently get points just for listing those candidates, even if you do nothing else. If you find the candidates and you list them, a lot of times you'll get a point for that. So let's look at this first question down here. Find the absolute maximum value of the function this on the closed interval. And I'm going to start by listing my candidates. So my candidates are my endpoints, which would be -1 and 2. Those are the easy ones. And then also my critical numbers. So I'm going to have to find the derivative, which is going to be 12x cubed minus 12x squared. We'll set that equal to 0 and solve the equation. And when you do that, you will get critical numbers of x equals 0 and 1. And so this problem happens to use every integer between the two endpoints. That's pretty rare. Usually that doesn't happen. And then once I have all my candidates, if I have the function, the easiest way to establish which one is the absolute max or min is to simply plug in the candidates. I have my left endpoint of f of -1. I'm going to plug that in. I'm going to plug in my two critical numbers of 0 and 1, and then I will plug in my last critical number candidate, which is the right endpoint of x equals 2. And so when we plug in -1, 3 times -1 to the fourth is 3. That'll be +4, so we get 7 from our left endpoint. If I plug in 0, you get 0 back. Plug in 1, you get -1. Plug in 2, oh crap. 3 times 16 is 48. 4 times 8 is 32, and that gives me 16. I wanted the absolute maximum value, and the maximum value happened right here. And in a free response situation, make sure you answer the question correctly. And even in multiple choice, sometimes they'll trick you up and put both options there. But when it specifies the maximum value, they want the y coordinate. What is the actual value the function achieves? They don't want the x coordinate. So the maximum is 16. It's not 2. If they want the x coordinate, usually they will say explicitly at what x coordinate does the absolute maximum occur or absolute minimum occur. Typically, or if they don't specify x coordinate, then you're usually going to answer with the y. So here's another one, except this one you're given a graph of the derivative, and anytime you are presented a graph or a table, always identify what that graph represents. And in this case, we are told 3 times that it is the derivative. We're on a closed interval 1 to 8. And this one, notice at what x coordinate. It's asking very explicitly for the x coordinate where the function achieves its absolute minimum. And so my candidates, I want to consider my endpoints, which are x equals 1 and 8. And I also need to consider my critical numbers, which is when the derivative is equal to 0. And I don't have an equation to set equal to 0. However, I can see that my derivative is equal to 0. It looks like 3 times at my left endpoint, my right endpoint. And since those are already candidates, I'm not too worried about that one. But I definitely need to include 6. So I'll go ahead and write all of the critical numbers. However, 6 is the only one I'm interested in. And what I would love to do is what I did in the last problem, is plug those candidates into the function to determine which one returns the highest or the lowest value. In this case, the lowest, we're looking for the minimum. However, they did not give you a function in which to plug these values, so we don't have that option. So we've got to find out another way to determine this. And when you're given the derivative does tell you if a function is increasing or decreasing. And so I can very quickly eliminate 6 because at 6, my derivative is positive and then my derivative is negative. And so there is a maximum, a local max at x equals 6 because f prime changes from positive to negative. And so I'm eliminating 6, and I could go ahead and eliminate 5 and 7 as well because those aren't even candidates. 7 is a very tempting one because it is the minimum of the derivative, but it's not the minimum of f. And so we're down to 0 and 8. And to determine which one is the lower of the 2 points, I have to know how much the function increases and how much the function decreases. And so looking at my derivative is positive from 0 to 6. That means wherever I start, I don't know where I start, but wherever I start, my function is increasing from 0 to 6 because the derivative is positive. And then for a short while, the derivative is negative from 6 to 8. And what we need to know is how much does the function increase or decrease? It is possible that even though the function increases for a long period of time, it could increase very gradually. And then when it starts decreasing, it decreases very sharply. And so the fact that we increase over a longer period does not mean that we increased a lot more. To determine how much you increase, in this case, we will analyze the area under the derivative. The area under the derivative tells you how much you increase or decrease. And if you look at this, I hope you can tell that this positive area is significantly, why does it keep doing that? That positive area is significantly larger than this negative area. And so by analyzing the area, I could say, I'm going to do this in math language, the area from 0 to 6, actually, I'm not going to do that. I'm going to say the positive area from 0 to 6 is larger in magnitude than the negative area from 6 to 8. Therefore, my minimum occurs at the left endpoint of 0. We increase significantly more than we decreased. And so since we increased a lot more than we decreased, my left endpoint must be lower than the right endpoint. X equals 1. I said x equals 0. Oh, crap. This is a bad question. Son of a... Okay. I typed this question myself, and I was not paying attention. This should be x equals 1. There. Now the correct answer is there. Ugh, that was embarrassing. Okay.